Hey guys, what's going on? In this video, we're going to be taking a look at how to build a tokenized Vault smart contract using the ERC4626 standard. Vaults are widely used in blockchain DeFi protocols, so it's definitely a great pattern to master as a blockchain developer. We'll start with showing how to use the OpenZeppelin implementation of ERC4626 to build a simple Vault smart contract, and then we'll look at how to add some customizations such as vault fees, and also adding hooks where you can implement your yield strategy code. So if that sounds good, stick around and let's get started. Okay, so first I want to briefly go over some Vault basics. First of all, what is a vault? In simple terms, a vault is a smart contract that accepts deposits of an underlying asset, usually an ERC20 token, and then attempts to generate yield or returns on those tokens by executing various strategies. They're used by many, if not most, DeFi protocols, including Aave, Balancer, Compound, Uniswap, and SushiSwap, just to name a few. An important characteristic of vaults is that deposits are tokenized, meaning that whenever a user deposits tokens into the vault, they receive so-called shares or vault tokens in return. These shares are also ERC20 tokens, and they represent the depositor's share of the overall vault funds, including any profits or yield on those funds. Let's take a look at the high-level architecture of a vault. The flow starts here with the depositor depositing some amount of tokens into the vault. Then they immediately receive share tokens proportional to the amount of their deposit. The vault pools together all of the tokens deposited by the various vault participants and uses some amount of them to execute yield strategies to try and earn profit on the vault holdings. These strategies usually involve moving funds around to different DeFi protocols. Some of the common strategies are yield farming, lending, liquidity provision, staking, and arbitrage. When gains are made with these yield strategies, the share tokens that the depositors are holding appreciate accordingly, and the depositor can withdraw their initial investment and any returns at any time by using the share tokens to redeem the underlying funds. So that's basically how it works. One important thing to keep in mind is that there are two distinct types of tokens here in the Vault code. We have, first of all, assets. This usually refers to the underlying token that the Vault manages. And then there are shares, which are the tokens that are actually minted by the vault that represent the depositor's share of their vault funds, which ideally appreciate over time. The shares are also ERC20 tokens that can be further traded, swapped, or invested just like any other token. So this design really opens up some creative possibilities that are unique to DeFi. Now I mentioned that we'll be creating our vault using the ERC4626 standard. So ERC4626, which was approved in May of 2022, provides a common API for creating tokenized vaults. It's actually an extension of ERC20, the token standard, so you can actually think of it as a token with vault-like capabilities. Prior to this standard, various DeFi protocols were implementing vaults in many different ways, and developers basically had to study each individual implementation and write adapter code in order to use them in their projects. Not to mention, all of these various adapter smart contracts had to be audited each and every time. So ERC4626 makes it much quicker, easier, and safer to create vaults that are compatible for use across different protocols. So what we're looking at here is the Ethereum improvement proposal for ERC4626. And essentially, this document is going to give you the most detailed information about the standard, including all the rules and logic that you need to implement in order to formally adhere to the standard. So you'll get the most detailed information definitely with this document. Now this other document here on Ethereum.org describes the standard at a little bit of a higher level, and it's really useful if you just want a quick and concise explanation of what each method does. So I'm not going to cover this in any great detail right now, but let's just briefly go over some of the more important methods. Well, asset is going to return the address of the underlying token managed by the vault. Total assets is going to give you the total amount held by the vault. And then you have, let's skip over these for now, and we've got deposit, which pretty self-explanatory. This is the method you're going to call to deposit tokens into the vault. And mint is actually called by deposit. You can probably guess that this is the function that's going to mint the share tokens, and basically, which is the underlying ERC20 of the vault. We've got withdrawal and redeem, which are very similar. These are both ways for the vault participant to extract their funds back from the vault. The only difference really is that with the withdrawal function, you're specifying the number of assets that you want to take out, whereas with redeem, you're specifying the number of shares that you want to then convert and then pull back in the form of assets. Total supply gives you the total amount of shares in circulation, and balance of. This is just one of the many ERC20 functions that you're able to interact with, given the fact that ERC4626 in turn inherits ERC20. Now back up a little bit where we are seeing different functions such as convert to shares, convert to assets. These are essentially helper functions, utility functions that perform these conversions. They don't actually send assets or shares, they just perform the mathematical conversion. And they are used under the hood of things like deposit, withdrawal, and mint to first do the calculation, and then these functions will actually perform the send or transfer of the funds. All right, so that's just a high-level overview of the spec itself. And with that, let's go ahead and jump into coding our Vault smart contract. All right, so the first thing I'm going to do is head on over to Remix, which is our online editor, our online IDE. And I think for this tutorial, we're going to use Remix just because we're going to go through a couple of iterations of this Vault contract, and Remix just makes it so easy to redeploy and retest all of the functions. So let's pop open the contracts folder here, and we'll just repurpose these kind of default contracts that it gives us. So let's say storage, we're going to rename this one, and we'll call this Vault. Okay, and go ahead and pop that open. All right, we can delete everything. Basically, I'm going to go all the way up to here, delete everything except the license identifier. I'll change that to MIT. And for the pragma statement, let's go ahead and use caret 0.8.20. All right, and let's define our contract. So I'm going to say contract vault. Now, remember, we're going to be inheriting from the OpenZeppelin ERC4626. So to do that, I'm going to say is ERC4626, and then my contract body. Okay, I'll pause here. Now, the first thing we want to do before we go any further is take a look at this ERC4626 implementation so we can see what kind of input parameters are needed from the constructor. So I'm going to go over to the OpenZeppelin. You can find this in OpenZeppelin under contracts, and it's going to be under token ERC20 extensions. Okay, and in the description of this video, I'm going to provide all the links that I use or talk about during the video for your convenience. So look for them there. And so this is the contract. This is the ERC4626 implementation, which implements the spec that we were just looking at. So you can see this is an abstract contract, which means we're going to be inheriting from it. And here's the constructor. So there's only one input parameter that the constructor receives, and that is basically the address of the underlying asset token, okay, of type ERC20. So basically, when we use this Vault contract, we can use any sort of existing ERC20 token as the underlying asset. That can be an existing token that is already out there on the blockchain, or it can be a token that we develop, but in either case, it should be already existing and have an address that we can then input to this constructor function. Okay, so back to our Vault code, and let's define a constructor. Okay, now we want to provide that address to this Vault contract and then pass it into ERC4626. So I'm going to say ERC20, this is the type, and we'll say asset with an underscore. Now we'll pass it to ERC4626. So I'm just going to copy that. And we just have to pass in the asset variable. Now, if you remember, ERC4626 in turn inherits from ERC20. Okay, so what we want to do now is define the name and symbol of our share token. Okay, so I'm going to say ERC20, and the name is the first parameter. So I'm going to go with OceanToken, which I've used in previous tutorials. I'll call it Vault OceanToken. Okay, now next parameter is going to be the ticker symbol. So a lot of times I'll see this convention where there's a lowercase letter V or a different letter prefixed by what you would normally use as the ticker symbol. All right. All right, let's pause there and go ahead and save that. Now the next thing we want to do is we actually want to create this token. Okay, so like I said earlier, you can use an existing token, but I think for this tutorial, it's going to be a lot easier to create our own token. Then we can regulate the supply and send X amount of tokens to our wallet right away. So we don't have to go searching for a faucet or anything like that. And this error message here is basically saying that the compiler doesn't match the Solidity version that I've defined. So I can just go over here and if you need to do this, just go ahead and adjust your compiler to match your Pragma Solidity version. Oh, and of course we need to import the ERC4626. So I'll go right above the contract and I'll say import. And this is the only thing that might be different between developing this contract in Hardhat and in Remix is that we're going to actually use the fully qualified URL here rather than the relative link to your node modules folder. So we'll go ahead and copy that from GitHub. And if we save that, then this error should disappear. Let's see, what do we got here? Oh, just a misspelling. ERC20. Okay. All right, great. So our vault is in good shape. This is a very bare bones, most simplistic implementation of a vault imaginable, but I think it's always good to start with that. All right, so let's go back to our folder structure here, and we don't need all this. Let's close this. Okay, let's pop open the number 2 owner. Let's actually rename it. No, I didn't want to delete it. Just wanted to rename it. There we go. So I'm going to say Ocean Token. And of course, you can call your token whatever you want. You know what? I think I'll just use I'll get rid of the underscore. There we go. Okay, so again, you can get rid of all the code here. I'm going to get rid of everything under the Solidity. I'll actually just copy the first 2 lines from my Vault contract and paste that in here. That'll be the same. All right, so now let's define our token contract. So the first thing I'm going to do is import the ERC20 implementation, and we're also going to grab that from OpenZeppelin. So that's going to be just here under token ERC20. And again, I'll grab that full URL and then come back to Remix and go ahead and paste it right in there. All right, so let's define the contract. Okay, so this is gonna be called Ocean Token, and it's gonna inherit from ERC20. All right, so constructor. Now you could pass the name and symbol into the constructor parameter, but I'm just gonna sort of hard code it in here for now. So I'll pass that directly to the ERC20 constructor, and I'm gonna say Ocean Token, and second parameter is gonna be the symbol, so I'll say OCT. Okay. Now within the body of the constructor, what we can do is we can mint X number of tokens directly to our wallet so that we have them available for testing. All right, so I'm gonna call the internal mint function of ERC20. And the first parameter is gonna be who do we wanna mint these to? So I'll say message.sender, which is gonna be my wallet. And let's do 1 million, just so we have plenty. So 1, 2, 3, 4, 5, 6. Perfect. And we'll do our decimal conversion here. So that's going to be 10 * decimals, just like that. All right. And now I've got a entire video on ERC20 tokens on my channel. So if you guys want to go through this in more detail, that video will definitely provide more insight there. But again, this is just a very basic bare bones token, and it's going to be perfect for our testing purposes. So let's go ahead and save that. All right, and so now we're ready to deploy. We'll deploy our token first, and then we'll use that resulting address to plug into our vault and deploy our vault, and then we'll test everything together. All right, so before we deploy, a couple of prerequisite items. First of all, you're going to want to have a wallet. I suggest Metamask, and you're going to want to make sure that you've got 2 accounts set up. Oops. All right, so as you can see, I've got account 1 and account 2, and you're also going to want to make sure that you've got some amount of Sepolia ETH on each account. So basically, we'll use account 1 as the owner of the Vault contract. So we'll use that for deploying, and that'll require some gas to pay for that transaction. And then account number 2 will be the depositor, or the client essentially, of the Vault. Okay, and so he'll do things like deposit tokens, withdrawal, redeem tokens, and all that obviously costs a little bit of gas. So if you don't have Metamask, and again, all the links are in the description of the video, but you can easily download it and install it here as a Chrome browser extension. And then as far as Sepolia faucets, there are a couple that I recommend. This one's really good. And there's one other one, the Infura faucet. And the reason why these two I like to use because they'll give you half of an ether, 0.5 ether, whereas some of the other faucets give a much lower amount. All right, and again, you can find the links to both of these in the video description. All right, so once you've got that, oh, and one more thing. It's really handy to have an Ethereum unit converter since Solidity only reads token amounts in Way, but sometimes you want to say, hey, I want to deposit 100 tokens, so what would that be? And then you could take this and kind of plug it in to Remix. And finally, one other thing is that I typically like to sort of set up my input parameters for testing various functions in Remix in Notepad first, because it's just a lot easier, a lot more visible, and it's easy to make mistakes in Remix since the input fields are so small. But anyway, we'll see that in a second. So, all right, so let's go ahead and compile our token contract first. So you want to go over here to the third tab and click on compile. That should just take a second. And then the next tab down will allow us to actually deploy. So what I'm going to do is I'm going to select injected provider from the environment dropdown, okay? And that'll allow us to deploy using our wallet. Okay, so go ahead and connect with Remix if you haven't already. And the next thing we want to do is go ahead and click on deploy. And there's no input parameters again for token since we've hard-coded our token data here. So we can go ahead and confirm that transaction. And make sure you use account number 1 for this in your wallet. And once that transaction is settled, we should see it right here. There we go. And see what I'm talking about, how it can be kind of cumbersome to, you can't even necessarily see all the parameters here unless you expand it. So what I like to do is just prepare that in Notepad and then input those here. All right, so for now, let's go ahead and grab the address. And what we can do, we can ensure that we have those million tokens in our account number 1. So I'm going to go over to import tokens and add the contract address. And you can see that it's already detected the correct token here. So I'll do add token and import tokens. And there we go. So our mint was successful. We've got our million tokens. And now what we're going to do is with account 2, we're going to deposit 100 tokens into the vault for testing. So I'll just go ahead and straight away send my account 2 100 tokens. So that'll be available for testing. So go ahead and do that. Confirm. And then we can also import that token under account 2. There we go. And it says 0 now, but once that transaction is settled in a few seconds, we should see the 100. It'll update right here. There we go. Okay, so now make sure you switch back to account 1 before we deploy the Vault contract. Oh, so again, what we want to do is grab the address of our token. Now we'll go back and let's make sure you're on the Vault.sol file. We'll go ahead and compile that. And we'll deploy that, but this time we want to add the address of our ERC20 token. Go ahead and confirm. And our Vault is being deployed. So we should see that pop up here any second under deployed contracts. Great. looks good so far. All right, so our vault is now deployed. So let's take a quick peek and see what we've got here. All right, let's check the asset function. Okay, that's correctly returning our token address. Let's see what else. Just spot check a few things here. Vault Ocean token. Great, so that's our share token. Symbol should be VOCT, good. Total assets should be 0. It's always good to make predictions before you check stuff, right? So this should be 0. All right, so basic functionality looks good. So let's try a deposit. Now, because the ERC4626 uses a transfer from for deposits, we actually have to give approval first on the underlying asset token before we try to deposit. Otherwise, it won't work. All right, so if we look at what are the parameters here, this is going to take an address and an amount. Okay, so like I mentioned earlier, I kind of like to prepare this in Notepad. I got to figure out how to do that better, but for some reason it's not letting me switch between browser and Notepad when I've got the video recording. Anyway, all right, so I've listed my accounts here. So I'm going to use account 2. Oh, wait, what were the parameters again? It was actually the spender, right? Spender, so that's going to be the contract, the vault contract. So I got to grab that first. Oh, and I'm looking at the wrong one, but that's okay. It should be the same. We want to do this on the Ocean token, right? On the asset. So spender and amount of tokens. So again, like I was saying, spender is going to be the vault address. And this is really annoying, but for some reason it won't let me easily toggle between Notepad. All right, so here's where I'm going to use the converter. And we say we want to deposit 100, so that's going to give us this number of Wei right here, which is a really big number. And so I kind of like to prepare this, set of parameters here, and then go ahead and copy them directly into Remix. So let's do that. Oh, and make sure that you're on account 2 before you send this transaction. All right, perfect. So we'll go ahead and approve. And, I don't know why, but sometimes it puts me back to account 1 like that. I don't know. So go ahead and reject that if that's happening to you. All right, so we're on account 2. Okay, hopefully it'll work this time. Sometimes I just get little hiccups like that, so it's always good to check. Okay, great. So I'm on account 2. I'm going to go ahead and approve that. All right, and then we want to check the allowance just to make sure it worked, right? So owner and spender. Okay, so I'm going to go back to my Notepad and let's just check, what was that called again? Allowance. Owner and spender. Okay, so owner is going to be my account 2. And spender is going to be the vault contract address. So let's go ahead and plug those in, allowance, and that's a read, so we shouldn't have to approve any transactions there. And great, that gives us 100. So we're all set to try our deposit. So we can go ahead and minimize our token, and let's go ahead and expand Vault. And let's see, what do we need for our deposit now? So we need the number of assets and the receiver address. Now that's not the receiver of the deposit, but the receiver of the shares, which is going to be my wallet address. All right, so first we have the number, 100 tokens, and then my wallet account number 2 address. Okay, so go ahead and grab that, and let's go back over to deposit. Where is it? There we go, and go ahead and click deposit. Now we'll have to approve this transaction. Go ahead and confirm. And we can kind of watch for that down here to see when that settles. And so once the deposit goes through, what kind of predictions can we make about the state of our vault and our wallets? So first of all, obviously, we should see 100 tokens in the vault. So we'll be able to check that with total assets. Total supply should also be 100 because that's going to be the number of shares that were minted, right? And so we can also check some things in our wallet. Wallet 2 should have basically 0 tokens because we've deposited all of them, but I should have 100 shares. All right, so we can check for those things. Now that it looks like that's settled, I think. Is that still pending? I can't tell. Let's check total assets. Okay, it's gone through. So great, that looks good so far. 100 total tokens in the vault, which is what we would expect. Now this will be our V tokens. Great, that looks good too. So let's check our wallet balances. Now, if I want to check how many shares I have in my wallet, what address am I going to use for that? Well, we're actually going to use the address of the vault because remember, the vault is the share token. Okay. So I'll pop open Metamask, make sure I'm on account 2. And first we can take a look at the tokens. 0 OCT, that's just what we'd expect, so that's good. Now let's import our vault token, VOCT. And looks like we have 100, so that's great. Everything's working as we expected. Perfect. All right, so the last thing we can do here is we can actually try to withdraw our funds. I think I'm actually going to use redeem. It doesn't matter, you can use either one. I mean, because we have 100 tokens in the vault and we have 100 share tokens in our wallet. So, it's two sides of the same coin. Which do you want to specify, the number of V tokens or the number of tokens? So you can choose either one. Let's do redeem. So that's going to be shares, the address of the receiver and the address of the owner, which I believe those should be the same address, both my wallet. Okay, so let's try to take, we'll try to take all of them back out. So redeem is going to be, basically the same as deposit, except we're adding the wallet address one more time, since it takes 3 parameters. Okay, so go ahead and grab that, and let's go to our redeem function. Redeem, redeem, redeem. Oh, we could also sort of look at convert to assets, convert to shares. It should be 100 in both cases because we're converting shares to tokens. This will become a little bit more interesting to look at once we involve fees and things like that, because then the amounts won't be equal. So we'll wait till we do that next to kind of play with those. For now, let's go ahead and do redeem. There it is, the expanded one. Okay. So let's go ahead and approve that. And so predictions, well, total assets should be 0, right? Because we've removed everything. Total supply. Now what's total supply going to be? Well, it should be 0 also because once we invoke redeem, our ERC4626 should actually burn those shares. So they should be basically removed from the global share supply. All right, so let's see. 0, great. 0, so far so good. And let's check our wallet balances. So we would expect to have 0 VOCT and back to 100 OCT. And that's exactly what we have. So great, everything is working so far perfectly with our vault. We've tested some basic deposit and withdrawal type functions, and everything looks to be working well. So next we're going to look at sort of how to customize our basic vault contract that we've made here, and we're going to add fees. So fees can be interesting. That's really how the vault makes money, how they earn revenue, how some of these DeFi protocols earn revenue through their vault. One of many ways, of course. And we'll look at some different ways to do that. All right, so let's talk about vault fees. Most vaults are going to charge some sort of fees, which they typically assess either at the time of deposit or the time of withdrawal from the vault. Personally, I kind of like the idea of charging the fee at deposit, just so the vault makes its money right away. And what if the user never ends up withdrawing their funds from the vault? But I'm sure there are plenty of good use cases for assessing fees at the time of withdrawal as well. So one thing we need to decide is when we want to assess our fees: deposit, withdrawal, or both maybe, right? So that's one decision point. And then the other decision point is how much to charge for the fees, right? And so our percentage is basically going to be written in what's called basis points. Now, you may have heard this term thrown around the financial world. It's usually used to describe percentage of interest rates or some other kind of, mortgage rates or something like that. And so 1 basis point is equal to 1/100%. Really, the only thing you need to know is, about 100 basis points would be 1%. Okay, so the tricky part about implementing fees is that you have to be really careful about adhering to all these different rules regarding fee amount. And we could probably see some of that in here. Yeah, for example, convert to shares must not be inclusive of any fees that are charged. Convert to assets must not be inclusive of any. And then there are some that must be inclusive, like deposit, I believe. Deposits must be inclusive of the fees, of any fees that are assessed. So you've got all these sort of logical rules that you need to be careful about implementing. The good news is that OpenZeppelin, again, to the rescue, they've provided some really solid example code for implementing fees here. And so they've got this example code in their documentation. And I've tested it with the POC that I created for this video over the last few weeks. I did find one bug, and that it was the basis point calculation was off by a factor of 10. So, I did some testing around it. I reached out to the OpenZeppelin team, and they were nice enough to correct it within like a few hours. They're always great to work with, super responsive and super helpful. So our strategy here is going to be that we are going to update our code to inherit from ERC4626 fees instead of directly from ERC4626. Now, I've in order to use this in Remix, I've just copied the code and basically saved it into my GitHub repository for this project, so we can use this directly here in Remix. All right, and again, this link will be listed with all the other ones in the video description. All right, so let's go ahead and update our Vault code. All right, so I'm going to go ahead and grab the ERC4626 fees link. And the first thing I'm going to do is replace our previous link with the new one, because since 4626 fees inherits 4626, we no longer need to explicitly import that one here. So this one is all we need. All right, so then we'll update our inheritance declaration here to be fees, 4626 fees. All right, so that's good so far. Now let's take another look at the fees SOL code and see what we want to do here. So basically, if we scroll towards the bottom, we'll see a couple of functions that are interesting. This group right here where it says fee configuration. So notice how these are all marked virtual. So we can override the ones we want to use in our deriving contract. So I think for this experiment, let's go ahead and assess the fee on deposit. So we'll use our entry fee. And so there are two things we want to set: the basis points and the entry fee recipient, which is going to be, in this case, I think we'll use our address 1 wallet, and that'll be the recipient of the Vault fees. So in practice, you may have, this is referred to sometimes as the treasury address, as you can see here. This could be another smart contract, but just for simplicity, we'll go ahead and use our wallet address 1 for this. Okay, so we're going to go ahead and override this one, entry fee basis points and entry fee recipient. So let's go back over to Remix now that we know what we're doing here. All right, so let's go ahead and set up some state variables for the owner and the entry fee. So I'm going to go right here above the constructor, and let's do address payable public owner. And now we can set that owner in the constructor. So let's say owner equals message.sender, but we need to cast that to payable first. Okay, perfect. Oh, that should be public. All right, and next one is going to be the entry fee. So that's going to be a uint 256. Let's say public entry fee basis points. Oh, there we go. That's better. All right, and we can also, so what we'll have to do is we'll define the entry fee in the constructor, and we'll leave the owner hard-coded. But you could do either way. You could pass in the owner. In my mind, that's never going to change, so that's a good candidate for hard coding. But for the fee, let's go ahead and set that at the time that we deploy the contract. So we can say uint256, and then we'll say basis points. I like to use an underscore since it's an input parameter. Basis points, and then we can set our state variable to that parameter. Entry fee basis points equals basis points. Okay, I think that's good. The rest of our constructor essentially stays the same. And now the last thing we need to do is override those two functions. So let's see, what do I want to do here? I guess I'll go ahead and grab the code from here just to save myself some typing. So I'm just going to grab this whole block and then delete what I don't need. Okay, yeah, ignore that. And so we said we want to override entry fee basis points and fee recipient. So I'll go ahead and delete the other two. All right, so the next thing we want to do is replace virtual with override on both of these functions. And then we can set the entry fee based on our state variable. That'll be set by the time we hit this code here, and I'll get rid of that comment. And this one we'll set to owner. All right, looking good so far. All right, so let's go ahead and deploy our new vault and test it out. So I'm going to go ahead and delete all my previous contracts. You can leave your token contract if you want and reuse it for this test, but I just like to start with a clean slate. And the one thing I do have to do is remove them from my wallet. Okay, because it's going to be a different token, even though it's got the same name. And where is it? Yeah, right here, I think. Hide OCT. And I'll do the same for account 2. And the vault token as well. And I'll switch back to account 1. Okay, great. So I'm starting fresh. And let's go back and redeploy our token. Compile and deploy. And then once that's deployed, we'll grab the token address and deploy our vault. All right, so I'll go ahead and grab that address. Now let's switch over and compile our vault contract, and hopefully it compiles okay. Looks good. And let's go ahead and deploy it. Now remember, we've added a new constructor parameter. So this time we'll paste in our address, but then we'll do a comma and 100 basis points. So I'm going to do 100. You can choose any value you want. This is going to equate to 1%. So I'm charging a 1% fee on deposits. But of course you can, try this out with whatever value you want. So let's go ahead and deploy that. Confirm. And while I'm waiting for that, let's go ahead and send our address to some tokens. First I got to grab the address. There we go. All right, and I'll go ahead and send 100 of them to account 2. Okay, looking good. Now I'm going to switch to account 2 because the next thing I want to do is do an approval so I can test out deposit with the fees. So let's see, I'm going to go to make sure you're on your token approval, and spender is going to be the address of the vault. So I'm going to go back to my notepad and set this up. So approve. I'm just going to change the vault token address. The amount will remain the same. We'll go ahead and approve and just make sure that you're still on account 2 here. Good. All right, in the meantime, I can set up my allowance check. So this is going to be wallet address 2 and the smart contract of the vault. Or I should say the vault address. All right, let's try that out. Allowance. All right, perfect. So now we can set up our deposit. So pop open the vault contract and we should be able to use our exact same deposit parameters from before, because this is the amount and the wallet2 address. So that's not going to change between test runs. And let's go ahead and do a deposit. Account 2, good, and go ahead and confirm. Okay, so as far as predictions here, now we're charging 1%. So our deposit is 100, but that's now inclusive of the fees. So we actually would expect our vault to have about 99. It's going to be a little bit more than 99 tokens, I believe, right? And then, yeah, a little bit more than 99. And then the actual fee is going to be slightly less than 1. So we can check our account 1 wallet for that fee to ensure that it's been deposited. Yeah, so let's go ahead and do that. Well, let's start by checking the total assets. So again, we said this should be 99 and some change, right? Okay, perfect. And of course, you can always verify that by plugging it in here to our unit converter. Yeah, 99.009. So it's not 99 exactly, because remember, we assessed the fee on slightly less than 100. It would be, it would be 1 exactly if we assessed it on 100, but our deposit was inclusive, because that's why we have that slight difference there. All right, so let's next grab our vault token address. Let's check our account 2. Now we said that we should have a little bit less than 1. Oh no, sorry, I'm getting mixed up. That a little less than 1 should be for the account 1 fee. All right, so let's check that. Okay. And here we can see that right here. So we should have checked this beforehand, but we started with 1 million tokens and we sent 100 to our good friend account number 2. So that left us with 999900, right? And this would have been 0 after the decimal point. So this represents our fee that's been correctly sent to account number 1. So that's looking good so far. Let's switch over to account number 2. What else can we check here? So our vault tokens, our amount of shares, should match the total assets of the vault, right? A little bit over 99. So let's check that out real quick. Perfect. That's a perfect match. Looking good. What else can we check here? Total supply should match that number as well. It does. And we can check our, we could check some of these functions as well. So convert to assets. All right, so if we check our our outstanding number of shares and plug that into convert to assets, what are we going to get? The same number. And the same for shares as well. Okay. Entry fee basis, we can check that. Yep, 100. That's what we plugged in. Okay, so I think this is all looking good. I thought maybe there was something else we would want to check here, but okay, so since that's working, we can go ahead and, well, what do we want to do? We could check our withdrawal or redeem. Maybe that's not so interesting since we've checked it before, so I'll tell you what, we'll put a pause on that for now. All right, so let's move on and talk about strategies. Now, if you recall, strategies are the way that the vault earns returns on the pooled tokens in the first place. And this can be any number of things: lending, staking, yield farming, providing liquidity, etc. So I'm not going to go into any one of those specific strategies because it would probably be its own long video. And the strategy is kind of the special sauce, though, that differentiates one vault in one DeFi protocol from a vault in another one. But anyway, what I do want this video to focus more on just the mechanics of the vault, what's going to be common for all implementations. But I do want to show you where that strategy code can live and where you can sort of hook into the vault. And so, yeah, so what we'll do is we will, I'll sort of mock a strategy and we'll hard code like a 10% return on any deposit. And so we could just see how the vault reacts to that and how it works and make sure everything's working properly. Because remember, the shares should reflect any increase, any return on the underlying funds. So we want to make sure that that's happening. So when I started looking at this, I took inspiration from another implementation of ERC4626. And that is this one right here in the Soulmate repository. Great name, by the way, for a Solidity library. And this one is actually authored by the team or one of the team members who came up with the spec in the first place. And so this is a little bit more opinionated, a little bit more complex implementation than the OpenZeppelin one. And that's sort of why I went with the OpenZeppelin one for this video. But I did really like what they were doing here with the internal hooks logic. So if you've worked with ERC20, this may look familiar. ERC20 has a before transfer and after transfer hooks. And similarly, this implementation of ERC4626 has a before withdraw and after deposit. So we can use these hooks to sort of kick off any sort of strategy code that we want to. So similar to how fees work, we can associate the strategy with the deposit or the withdrawal, or both, depending on what we want to do. So here's the hook functions, which we can override in our deriving contract. And then these are going to be basically called from various deposit and withdrawal functions. Deposit, mint, withdraw, and redeem. So you can see here, for example, in redeem. And it's really important that this is called in the right place in the code. So yeah, with that said, let's go ahead and grab some of this code and implement it in our Vault contract. All right, so I'm going to start by just copying this internal hooks logic and pasting it into my Vault contract. So go ahead and click on raw here. And there it is right at the bottom. So I'm just going to copy that, bring that back over to Remix. And I can sort of delete all of these deployed contracts for now. Okay, I'm on my Vault contract. I'm just going to paste that right down here. Okay. Now, what we're going to do is we're going to set up a sort of mock strategy. So since my account 1 has, starts out off the testing round with 1 million tokens, what I'm going to do is write some logic so that with every deposit, my wallet account number 1 sends 10% of that deposit back to the Vault contract. So in a way, that's going to simulate like a 10% return. All right, so let's go ahead and set that up. First, I'll set up the interest amount. Let's create a new variable called interest. And that's going to be equal to the amount of assets divided by 10. And that should give us 10%. Okay. Now let's do the transfer. So we can use the safe ERC20 that we're inheriting from ERC4626. Safe ERC20, there it is. And let's do, there's a safe transfer from. Okay, now this function is going to take 4 parameters. The first one is what we're sending, then from who, then to who, and then how much. So first let's specify the token that we're sending. And so we can kind of reuse this code from earlier, ERC20, and then inside that, invoke the assets function of our 4626, and that's going to give us the address of that underlying token managed by the Vault. Okay, so next we have from. That's going to be from the owner, which we've defined up here. And then we're going to have toHoo. That is going to be the address of this contract. So we can say address this. And finally, the amount, which is going to be interest, which we've defined just above. This expression is not callable. ERC20. Oh, this is just a spelling mistake. So this should be asset, singular. Oh, and I've got this in the wrong hook. So we said we wanted to do this at deposit, not before withdraw. So let's just move this over to the next hook. And we'll leave the top one empty because we're not really doing anything on withdrawal. And then we can remove shares because we're not actually using that parameter. There we go. So save that. That looks good so far. Now the next thing to do is figure out where we want to actually invoke this. So I'm just sort of following the original code here. And we can kind of just take a quick look of where all this is getting called from. At the very end of the deposit function, the mint function, and the way OpenZeppelin has these broken out a little bit further, like there's a deposit and there's an underscore deposit. So it's going to look slightly different. All right, so I'm heading back over to Remix, and what we need to do essentially is override 4 functions: deposit, mint, withdraw, and redeem, since we're now calling hooks from them. So we need to override those and define them in our Vault contract. So what I can do is navigate through my dependency folder here, OpenZeppelin, contracts, token extensions, ERC. So we can grab them right here from our original ERC4626. And if I scroll down about halfway, I'll probably see the deposit. There we go. Deposit, mint, withdraw, and redeem. And they all happen to be right together. So that just makes it really easy. So I'm going to grab those 4. And I'm going to go ahead and paste them in my Vault function. I'll do it right underneath the constructor. Okay. So owner. Oh, so we have a conflict now since we have a state variable called owner, and then it's not really a conflict. It's not a true error, but it's saying, hey, for good measure, you probably shouldn't have a state variable and a input argument with the same name. So let's go ahead and update our constructor state variable, or I should say our state variable. I think that'll be easier. So we'll say Vault owner. And we just have to update that in like 3 places, I think. In the constructor, and then down where we're, specifying it for the fee recipient. Oh, one more place after deposit as well. Okay, we should be good there. That error is now clear. Okay, so we want to call after deposit with 1 argument, which is going to be assets. So I'll just copy the name, and this is going to be for deposit and mint. And this is going to go right before the return statement. Okay. And we'll put it in the exact same place for mint, right before the return, just because that shadows what they're doing in the soulmate library. And just for good measure, even though we're not using the withdrawal hook, let's just go ahead and set that up just in case anybody wants to actually try that. So that's going to be in withdrawal and redeem, and that's going to go this time before the underscore version of the function. And let's see, what's this taking again? Assets and shares. Because we haven't really deleted shares, we haven't decided what we're going to do with this yet. Okay, and we'll put it in the same place here in the redeem function. Okay, so we should be good there. We should be all wired up with our strategy logic. The hooks are being called in the right place. And so one thing also to consider is whether you want to have all this strategy code in a separate smart contract or if you want to have it directly in your Vault. Personally, I don't mind having it in my Vault because I consider that sort of part of the primary Vault functionality. However, I did create a strategy smart contract that anybody could use if they feel like having it separate, similar to, so you'd inherit it in the same way that you would inherit the fees. And so all that code that we just went over is right here in this abstract contract that you could use. So if anyone feels inclined to try that out, feel free. I'll leave this up here pretty much forever. All right, I'll close some of these windows I don't need. Okay, so let's go ahead and deploy our contracts and do our final round of testing. Now, our main goal with this round of testing really is to make sure that after we've deposited and then, withdraw our fees, that 10% underlying gain on the Vault tokens is reflected in our new balance. Okay, so let's start with the token. Let's go ahead and compile and deploy that. And injected provider, deploy. All right, tokens deployed, so I'll grab the address and let's go to the Vault. Go ahead and compile the Vault contract. And let's deploy it. So we've got our address and then base points. We'll stick with 100 for this round again. So that's going to be 1% fees. And we'll deploy that. Perfect. And while we're waiting for that, I'll go ahead and import the main token and send some over to account 2 as usual. All right, and we'll go ahead and import that in account 2 as well. Perfect. Okay, now that both contracts are deployed, we will, let's see, the first step is to set up our approval. So we're approving 100 tokens for account 2. And let's see, I'll need my Vault contract address for that. So we've got spender and amount. And we'll go ahead and approve that. And this time I'm not going to check the allowance. I'm going to assume that worked. Hopefully it doesn't break this one time that I'm not checking it. All right, and we will grab our parameters for our deposit. And this doesn't change. This is still the same. And let's give that a try. Oh, and I got to make sure I'm on account 2. I should be right. Yeah, because I just did the allowance. All right, so we'll try our deposit. Uh-oh, gas estimation failed. Interesting. All right, so of course the first thing I'm going to check is my allowance to see if that happens to be the problem. So that's going to be owner and spender. So you should just have to replace the second parameter here with my updated Vault address. And let's see if that worked for us. It did not work. See? Jinxed the one time I said I wasn't going to try it. So I don't know what happened to our approval here, but let's just, try it from scratch. That's really weird. So let me retrace my steps here. I'm on account 2. Ocean token, okay. And let me just check one thing here, 908. I just want to make sure that that's the correct address that I initiated this with. Where is it? Asset. Okay. Okay, good. That looks okay. Weird. All right, so approve. And let me make sure I've got the right Vault address. It can get really confusing quickly when you've got all these addresses and tokens. I think that looked like it was the same one though. Okay, weird. Maybe, I don't know what happened there. Let's just try it again. Okay, so I'll make sure I'm on the right one first of all. Was that the problem? No? Okay, approve. I'm going to wait till I see that it's been settled. Yeah, it looks like my... Oh, is this just never going through? Let me try this real quick. Oh, okay, it worked that time. I don't know what happened. Okay, so let's try our deposit again. Nice, much better. Second time was a charm. Okay, now a couple of predictions here. So we should see that interest reflected right away when we check the balance of the vault. So, you know, we deposited 99, a little bit over 99 tokens plus 10%. So it's going to be just shy of 110 is what I would expect. Total assets. Yep, perfect. 109 and some change. So that looks good. Yeah, there's our interest. That's nice to see. Total supply. So again, that's going to give us the outstanding shares. So I don't believe that would reflect this, right? That should be, yeah, that should be more in line with the initial deposit amount because the shares themselves have appreciated. Yeah, that's correct. Okay, great. So the last thing to do is to, well, okay, let's check our wallet balances and then we'll do a withdraw or a redeem. So let's check wallet 1. Yeah, right. So that reflects, this part reflects the interest and then the transfer for our mock strategy. So that looks good. All right, let's go back to 2. 0 OCT. Okay, so perfect. Now we just want to execute a redeem. And that's going to take shares and then the address of the receiver and owner, which will be the same. So basically we can reuse our old redeem parameter list here. Very convenient. Uh-oh. So what could be wrong with our redeem? Cancel transaction. First I'll check my input parameters. Oh, okay. So we've got to adjust our number of shares. It's not going to be exactly 100. That's the problem. Okay. So we can check that by looking at, basically it's going to be this number. I mean, it just happens to match since we're the only depositor, but we could check our shares in our, in fact, let's just do that just for good measure. So I'm going to copy our vault address, which remember is the same as our shares or V token address. And let's just import that into account 2 to be sure. Yep, and so that's going to be that same number as the total outstanding shares. So basically we can use this for our redeem function instead of the 100 that we previously had. So this should work, hopefully. Redeem, redeem. Where are you, redeem? There it is. All right, let's try that again. Good, no gas estimation error. Always a good thing. All right, that transaction is pending. And so once that goes through, we can check a couple of things here. Again, we should have, I believe it would be 0 assets, right? 1 asset. Okay, where's that coming from? The 1. Interesting. Total supply is 0. This might be just a rounding thing. All right, but the most important thing is that our wallet should reflect that 10% gain minus the 1% fees. So let's take a look at our tokens. And here's the takeaway right here. So our OCT is now 109. we started with 100, so we've made 9 tokens interest basically on our little venture into the vault. Great, so that is working exactly as expected. And I think that concludes our testing round here. Everything is looking really good with our strategy. All right, guys, well, that about does it for this video. Hope you enjoyed it. If you like this content, please consider subscribing to the channel, and would love to hear what you guys are planning on using vaults for in your own projects, so let me know in the comments. Other than that, take it easy and look forward to seeing you in the next one. Peace out.